coding. So the observe in the field that in middle 30s or the early 40s who had the experience in the programming, Can you see my face? Okay. Who connect programming, that is the barrier of to learn or go little further to the programming. Why? Who knows that how complex it is? What is the syntax and the installations, and there are lot of technical things they will have to deal with if you are involving with the C plus or the Python, whatever it is. It requires the too much of the upfront planning or upfront the learning to go into this. Zoom is not responding. The Zoom is not responding. Is it? It's okay. It's working? Okay. So it says the Zoom is not responding. If you have any issues, please text it, and we are observing and listening the text, and we can respond it according to that. If you are unable to hear me or unable to see me, you can respond it. Okay. So the most of them who are in the industry, who are reluctant to learn or starting or embark the journey of this programming, because of the reason who knows the complexities. So they don't know what are the other alternatives to approach this programming, to enjoy the machine learning or enjoy this data analysis. This is what the future, what it's being advertised in our the curriculum, in our the small course providers. So in here we firstly understood that the most complicated machine learning or the programming is the compile, the source code programming, which is related to mostly the C plus or some other the Pascal related languages, which has a lot of syntaxes. Lot of syntaxes mean you have to write in a proper way. If anything missing, it will run whole the bunch of the program. It will create the errors at the last. So sometimes to deal with this type of the programming is very, very difficult. So it's only the privileged who are committed for that. So then another type of the program comes up for those who are not in the computer domains or the major in a computer. That's the interpreted programming. So then little easy with that. Line by line will be translated to the program which the machine can understand. So where we can easily connect our logic with this Python, but this is the open source. Many programmers involved into that and make a lot of the contributions which becoming so popular to go for the machine learning. A huge number of the machine learning applications are freely available. So the Python becoming the second pop out, the second popular language after the machine learning comes up. Even it is very easy related to the C++, but still our professionals are hesitant or not feeling the comfortable or complacent enough to do the interpreted programming. So again, we need some easy avenue to get the access to the programming. So today is our introduction. So in the first day, what are the easy access we have? So if you are not the programmers, so what are the easy access we have? If you are the programmer a little bit, but very difficult to make the problematic or the very content related programming, then again you need to go for the new programming language, easier than the Python programming. What are the available options you know or you thought other than the Python we can do? Easy access to do the programming. Do you have any idea? So while you are make some sounds, we will count for you that evaluation. Anyone? Do you have any access? Do you have any idea what sort of the ways we can access the programming the programming means the data analysis or whatever it is. But the avenues is only to reach the data analysis, the programming is the way. So another ways which recently very popular, there's a two ways we can approach it. One is that the KNIME, that's a graphical related and human friendly programming. Graphical related means rather than doing the syntax, rather than doing this the coding and write the different colors and make them complicated, we can invoke some particular symbols. Inside that, some of them already written the code. So all the popular code, all the machine learning tools already written inside that particular graphical format. So while you are invoking that, you are able to run the KNIME or Scratch. A lot of things are there. KNIME is the one of the very popular as well as the very authenticated and verified and acceptable the machine learning tool accepted by the several Q1 journals, even the computer related journals. Another one is that vibe coding. Have you ever heard the name of vibe coding? Anyone? Do you want to call one by one the names? Have you ever heard the name of vibe coding?
Have heard about it, yeah.
What's that? You heard about or never?
I have heard about it, but I'm not sure what it is.
Okay, that's good. So the vibe coding is that now it's becoming the vibe coding plus, vibe coding ultra and all other things. This word particularly introduced by the Anraj Karpade, who is the pioneers of introducing this vibe coding. That rather than doing this programming, why we need this programming? We just let us to write in English or whatever language and interpret it directly to the computer programming. Why need some programming with the same complexities and translate to that machine? Why need that? We just need just write the what you want. I want to optimize the cost. I optimize the the quality. We just write those things. So we can access the things directly to our human language. Why need some other language, some other things to make it complicated? So there are two ways of the approach. It has its own pros and cons. It has the own pros and cons. We will discuss it one by one. So before going through this, we should have some basic understanding of what is the machine learning is. All of them are talking about the machine learning. What is the machine learning is? Is there any opinion or the you have to share what is the machine learning is? It should not be the monologue. We are intent to make it the dialogues and contributing both way. It's not sermon at all. So, and we can make it in the proper way. Of course, within these 20 hours, 30 hours, sometimes to catch this out of the big context, it's difficult, but it would be the cornerstone. So then the dialogues maybe they encourage or catalyze the intentions to quest the machine learning stuff. So please let me know that you have any idea about what is the machine learning. So then we can go through it. Any idea what's the machine learning is? Let the machine learn or make the machine learned. What's that? Let the machine learn or make the machine learned? Which one is? Any opinion? Any one of you?
Uh, it can make predictions without being programmed.
Yeah, somehow we can say that as it is somehow. Yeah, of course, that's the valuable opinion. So let's go with that one, machine learning stuff. Very basic one related to myself. Okay. So in my class, I'm just doing that, the contract management or the condition of contract, which is my favorite topics. I involve with the masters or the bachelor students. So where I want to judge, I want to predict the someone else. This is the one way. There's a 3 or 4 branches of machine learning. So what is the most popular? We just starting with the very simpler form, and then we can go deeper and deeper. So in the machine learning, I have to judge. I want to this one, okay. So how to learn to judge? I want to find who are the students who got students are good, the A plus or A. The what are the features related to that? What are the field which are related to the A plus? What are the things can be correlate with the results of the students? What are the things? Just name it. Is index number. We have the lot of data. Last 10 years, I just collect the data. We have more than almost 1,000 data. So where we have the several columns, each and every rows representing one student. So each rows having the name, index number, what else? How many hours who involved into the study, and what else? What is the Z score who earned before entering the university? What else? Which area who is coming from here, his or her eye color. We have the lot of data. We have the data. Our university record the data. And later it's a past one, retro analysis. No, we have the past one. We have the results. So we have the results. C minus, C plus, A plus. So I want to find that how these features connecting to his results. Why I want to learn it? Why? What's the intention of mine to learn this? What would be the intention?
Any new students come to, we can predict the results. So if any new students come to the university, so we can
Yeah,
predict their results.
we let the machines, we let our model to understand the stuff, and we can predict something in the future. That's what we call the supervised machine learning. What's unsupervised? I will let the discuss later. Supervised machine learning is retro analysis. We have all the data. With the data, we try to produce. So we have these all the features, what we call features. What are the features? How many hours who involved, and what is the GPA what is the Z score who has, and how many the attendance percentage of the classes. These are the features we call. And what is the output? The results is the output. So we try to correlate these features into output. So that's what we call supervised machine learning. We have the access in both way. So let's go with that, how we can do that. So after years of teaching, you can often sense which student will do well. That sense is built from the machine learning simply writes that sense down as a rule using the data instead of the intuitions. So the experience, the lecturer who can judge it by seeing that through their senses he or she has, and who can judge it, these particular students, would produce or yield some good results at the end of the process. The human way, there is no tacit knowledge. Tacit. What's a tacit? Have you ever had tacit knowledge? No, it's shared here. So the tacit knowledge, that means the knowledge is very easy, not easy to transport. So like that, in our culture, what's that? To get the gloriness or get the what we can call it. So the cooking, sometimes the cooking we cannot teach each and every details. If you want to cook like your mother, you have to spend the significant amount of the time, and then only you can get that the actual knowledge in how can you do the cooking. And same time is what we can say, the swimming. It's not such easy to learn the swimming at the YouTube. So you have to pattern, you have to experience. That we call the tacit knowledge, tacit knowledge. It's very difficult. Geometry is not a tacit knowledge. Logic is not such tacit knowledge. But the enlightenment, of course, in our culture, enlightenment, we have to go through some pathways with the guru and all other things. So we can call it the tacit knowledge. So how I can judge the students who will produce the good results, it's some sort of the tacit knowledge. Okay, so but what's the problem with the tacit knowledge? It will take the time. It will 20 years. After 20 years only I can judge. At the time I am on the verge of retirement. So what's the benefits of learning those things in such a way? So we make some mathematics to replicate or copycat the human way of learning. Okay, that is the basically you can understand. It's not the theoretical or technical definitions of the machine learning. This is how I understood. This is how I try to escape from these initial questions, which make me to hurdle to learn the programming. I try to understand in such a way, I just move away. So that is the best way to get penetrate or get involved in the machine learning. You don't need to know everything theoretically. You just make and go to the thing. So in my data, I have 1,000 past students and 10 years of the record. 7 recorded details each. That means each student's having the 7 features, age, number, like that, 7 features. And one is known results. This one is the output. The 7 is the features, 1 is the output. Okay, this is how the data is orchestrated, that detailed in such a way, where name, ID number, height, study hours, attendance, pre-university score, that means the Z score, and English level. Of course, the English level having the very strong influence on the bachelor's, the results. Of course, no? I think that you can hear it now, isn't it? Can you hear me? Am I audible? Am I audible?
Yes.
Yes. Okay. Thank you. Please let me feel that I am talking with the people, not with the screen. Okay. Let me feel in between while I'm asking the question. So we could call it, this one is the feature. So some features as an expert, even not the big expert, but the amateur or novice in the field, but I can say it. Index number has not much the strong influence, isn't it? Index number, if you are good at numerology, you can do something, but in my case, I don't believe it. Name also, I don't believe it. height also. Sometimes our conventional way, the shorter one smarter, I don't know. So we can remove it. So the study hours, of course, attendance, of course, and pre-university score, of course, English level, definitely. That's how it's worked. So we try to remove these columns. We try to exclude or filter this column. Why we want to filter? What's the reason? We have the supercomputer. We just put all the details. No need to worry about that. The computer will find it, which is important, which is not important. Why you are intervene that? Why? Why we are going to filter those? Any idea why we are going to filter those? The machine can develop its own strategy. Sometimes it will find it some particular pattern of the ID numbers producing the good results. Why you are let them not to involve in this? Why? Because sometimes machine learn some misinterpretation with the results. For example, if continuously the 5 students with the same 042 got the A plus, what will happen? It will definitely says it will be the index number is the severe influence on it. What will happen is try to overfit, like that the height. Sometimes continuously 5 students with the shorter heights may produce the good results. What the machine will do? It tries to predict in a wrong way. That's we call it overfitting. So this, the exclusion and excluding the features, we call feature engineering. Very fancy word. Feature engineering. Feature engineering can do by whom? The professional in that field. The civil engineers can do that. What are the features having the influence on the extension of the time? That we call the feature engineering. You can hear me, no? After the phone. Yeah, that's we call the feature engineering, that we just exclude the columns which are not relevant. For example, sometimes we want to remove this column due to the ethical reasons. Why? For example, one camera can find someone else as a culprit, the possibility or suspect in an airport. Sometimes if you have put all the details there, can be apprehended or it try to predict as the culprit or the suspect. So at the time we should have some ethical reasoning. We should remove that column and remove that features before putting into the machine learning. So before implementing these systems, now we should submit the ethical clearance. So at the ethical clearance, we have to present it, that particular column. So all the columns are something professionally connected, not with the stereotype or not with the prejudgment or prejudicial the mentality. It should be with the professional connection. So this is what we call it feature engineering. Yeah, the keep, what do you want to keep? Plausibility assurance, that possibility of having it, professional judgment. What you can drop it? There is no any judgment. Sometimes for the big data, sometimes what we are judging that as not relevant, sometimes they may have some very secret relations. So one of the example for for the story to make you connect these the interesting things of these, and witch hunting, that the mid time Europe, that's popular, someone else who find the one woman who are doing the witch huntings against the humans, like the black magic. So that's the incidents recorded. They find it, the incidents are recorded almost all the time in drought period, not the rainy period. But that the witch hunting and the drought period, of course, there is no any relations. No? There is no any relations. But later, the socially they just interpreted it. It's a real story, real story. At the drought time, there is no any paddy work. There is work in the paddy field. So who has nothing else to do? We have Facebook, we have the TikTok and Twitter. Who has no work? Who just involved? What's happening in the neighbor's house? So sometimes may have, if the social studies, we can't avoid all the things. But this type of the studies, we can exclude it. Okay. But you want to understand that we are smart humans, smart beings, but machine is not. Machine is not. Sometime it try to learn. What do you But we can do that. Somewhere in here. What I already said, that the model happily learned the nonsense. Of course, we are smart humans. We know that how to learn it. We will not any stupidity assumptions. We know something, but the machine try to learn the stupidity. If in any 1,000 rows, some irrelevant column will look meaningful by the pure chance. The model cannot tell the luck from the low. So then what we can say that, so if the height lesser than 150 continuously getting the A plus, the model is so confident. If your is lesser height, you will get the A plus. So what's that mean? You should reduce your height. And overfitting, that's what, even though the useless details, the models memorize the past, the cohort, instead of learning the general rule, they file on next year's student. So in here, the earlier students, the same thing, the previous pattern and overfitting is the same thing. Some minor details are there, but I try to avoid it against that the one particular area person, one particular religious background. Unable to hear. This overfitting is that means that they try to learn some unnecessary details which are not relevant to the predictions. Hidden bias, the names and ethnicity against the problems comes up. Name and ethnicity and gender, they feed them in, and you may build a system that quietly discriminates. Sometimes the one who are involving into that may have some influence on their bias. And then loss of trust, if any bias comes up, that model cannot be the good model. So that is the basics of it. So what we can do that after that, so we try to make it the two different set. So we have the 800, the 1000 datas. We try to take it out the 800 datas and let the machine to learn on it. Let the machine learn on it. So after the learning that, we allocate the 200 data, rest of them, to verify what they have learned is correct or not. So how can we divide that? We can divide in several ways. One is that first 800 and last 200 is not the proper one. We have to do the several sampling method. One sampling for the stratified sampling, we just collecting this group of the people, we just collect the same number of the sample for testing, as well as the later we just select the same number of people for the testing data, learning data and testing data. So these divisions of 800, 80% for the learning and 20% is a universal rule. There is no any law. It should be 80-20. Some features, if the features are high, what's the features? The features are like the English knowledge or whatever it is, that's the features. No? Features are high, sometimes we can split it, the 70 and 10 for the development and rest 20 for the verification. Sometimes we can do that in some type of the sample, 80 for the learning and 10 for the development and 10 for the verifications. That depends on the data to data. There is no any universal acceptable rule. What should be the what proportion should be the learning and what for the what for the testing. So our intention is what? We just select the 800 datas, we make them to learn, make one functions with these features, function of what, in such a way you just try to understand. It's not the function, it has several ways, but it's a function of number of hours involved, the whether the attendance is there or not, and those details. English levels are the function. So we can make the several functions. In Excel we can make the linear function, exponential function, there are several functions. Here also we have the several functions. It's not the functions, theoretically it's not the function. Those things you will discuss in the second classes. What are the machine learning methods are there, what is the mathematics behind, you will learn a little bit and you can go through it after that. But to apply those machine learning, there is no necessity, there is no any needs to know all the things details. Okay, still problem? Logistic regressions, k nearest neighbors and random forest we try to mimic and try to understand this. It is the formula methods, some sort of the formula method, linear regressions and exponentials and whatever it is. But the next classes you may have some taste on those basics. Okay, after the learn those things, we can find it one way of the programming and one way of the functions through which it's able to find which are the features having the high influence, and with these we can make the judgment of the future students with these features. These features are freely available, we can take it and we can judge little bit on the people. And what more than the judgment, we can give the suggestions to the students in which way he should improve himself, to prepare himself to learn and to get ready to be a good student or able to produce the good results. So that's most important. That's we call the interpretability or the mitigation measures, whatever it is we can do. In which way the one who want to prepare himself to produce the good results. So then after the learning something, what we want to do, we want to verify it. What's the verifications against that accuracy? There's several type of the verifications are there. How much accurate enough of all students, how many did we classify correctly? It's quantifying our accuracy. And precisions of those we predicted would earn A+, how many actually did, how much is closer enough to consistent with this prediction, and if we are recalling that whether it's producing same thing or not, that's a recall repeatability. And confusion matrix we can make it whether it's correct, while it is correct, how many of them are predicted as incorrect, while it's incorrect, how many of them are predicted as correct. So that's we call it the confusion matrix, through which what we can measure, how much accurate enough our predictions. That's the things we can measure. So the prediction is only useful if the changes what we do, we can do the early warning. By week 4, flag students, for those whose attendance, we can do some early mitigation measures, early measures to, rather than filing them, rather than indicating them as who are going to file, but we can give the advice in which way he should prepare. And targeted support and honest feedback, these are the things we can do it through these machine learnings. So will this road project need an extension of time? So now you are the civil engineering students, you are not interested anymore about the students who got the A plus or not. To you A plus or A minus, it stop after you finished the masters or PhD, the bachelors. So you are not interested enough. So how can we connect this same logic and same concept to the civil engineering project? Any ideas? So don't see that. Okay. So any idea how can we connect this to the civil engineering project? So in this type of the predictions, what we want to know, you want to know the detail, what? The detailed data, what are the influences, what is the results. We need the entire way. We need the avenues, we have the avenues to access the both side. Then only we try to predict this. So that is the data setup we need. So can you assume it what type of the data we have, we can produce the same type of, we can emulate the same type of the model in a construction industry. You're from, all of them are from civil engineering background, no? Isn't it? So what type of the data?
How long the project is taking? What are the type of contract involved?
Yeah, there's sometimes the extension of time. It works, no?
Private message versus
If any important, just give me the hint.
okay, sir.
If anything relevant, please let me hint. Okay.
Just private message.
I saw some private message. Now it's better. Now it's better. Still that issue persists. Now it's okay. Can hear you now. Okay. Yeah, okay. So there's nothing else. Any serious questions? So please, if any serious questions, let me know. I will check it. Okay. So one assumptions I did that the extension of time. What's the extension of time? Of course, you are all of them are civil engineers. You know that. What's the extension of time? So initially we decided one particular span of the time within which the project should be completed, but due to some reasons attributable not to contractor, we can give some additional span of the time to complete the works. What are the reasons we can say not attributable to contractor? What are the reasons? Adverse weather it would be, and the engineer not give the drawings, and some crises and pandemic, Aragalaya, what else? Some blasting happens, war, yeah, whatever it is. And so we have for RDA, one RDA project, so we can say that RDA last year having the project more than 10,000 projects they have. Some of them are extension required. Extension required means we should give some more time to finish the work. Some of them are not extension required, some of them. So we can, what are the features having the influence on whether we can finish the work within the time period or not? What are the features? Yes, the past contractor performance, of course. Past contractor performance. We can say that the contractor's performance last year. Okay, we can say that. The where it's being implemented, if it is the congested area or not. Sometime land acquisition problems comes. Holders who are adjoining the properties may creating the issues. Region, of course. If it is Mullaitivu or Hambantota, no rainfall, there is no extension, isn't it? So region. What else?
That's the contract they are using.
The type of the contract also sometimes is the reasons for that. Sometimes there is BD2 having the wide interpretations of to in which reasons, which occasions we have to give the extension of time. Somewhere it's not there, so that's also have the minor reasons. And something we can categorize those features. Those features, how we can select? Through the experience, through the our professional judgment, we can select the features. Of course, we can neglect the features. What are the features we can neglect? What is the ethnicity of the contractor? No need. No need. Huh? Weather patterns of Sri Lanka may have the influence, might be. So those features we can take it out. And of course, the form of contract, we can say that the MDP and of course, it has the very strong influence on who is the sponsor. If it is the World Bank or something, the contractors having the full credibility and contractors have the full trust, the payment will be paid. So who can make all the efforts to complete it within the time. But if it is the government funded, always we are reluctant to do it. No? So that those are the features, we can take it. And at the time of future, if you are making the same type of the contract, this model can suggest to you make little lengthier span for these projects, this complicated project. Rather than making the shorter span and after that all these legal issues and comes up and we can make the lengthier, or we are expecting to be a lengthier. Sometimes if you default a lengthier, again the rainfall, the contractor may request the extension. So we can ready to be lengthier. So we can all the preparedness to do the lengthier. So what else we can do that? Cost overrun also we can do the same thing. Cost overrun also we can do the same thing. What else we can do that? We can do the price predictions. A lot of ways we can involve in the price prediction. That's why we call it that we have some correlations. For example, the price of the cement having the very strong correlation with the dollar market, crude oil market and gold market. So those are very sensitive, that if any bigger waves comes up, the firstly we can notice in the dollar market and the gold market. So the second wave is the cement. So according to this market changes, we are able to predict. What is the prediction, the time period? So we want to compare is what? The 2 months earlier dollar market, 1 month earlier gold market, having the effect of cement price. So we can make some wider context, the overall the construction cost increment, price escalation, overall construction escalation connected to what? Dollar market and something else and something else. With that some time extends, that's we call it lagging correlation. Lagging correlation means not to on-time correlations. There is some effect on the what's happened little early. So we can make the legal. So we can connect some studies. I can find some studies while I'm checking this. How the construction cost increases with the number of features. What is the land market values, land market index, how much of the loans derived last 3 years of the house built on in the bank. Those are the features we can make the connector and we can predict it. So the construction business becoming so complicated, so the relevant and conservative conventional tools are not enough to sustain this competitiveness. So where we want to come up with these new tools to sustain or cope in this the complicated situation. So where the machine learning stuff would be the one of the easiest way to get involved in this complicated one. So again, the form of the forecast to mitigate before the delay occurs. So there are several research done on these, and the variation happens or not. There's some research comes up, the variations comes or not to one particular project, and with the contractor's ability and complexity of the works, we can say that whether this project ends up with the arbitration or not. That's one of the studies have already done. With the data, we have the data, arbitration happens or not, we know that. We can apply the same knowledge here, we can predict it whether disputes comes up or not. If the disputes comes up, that's the almost failure of that entire project. So we becoming know that there is a possibility or higher probability of triggering the disputes on that particular contract. What we can do that? We can do all the mitigations of the disputes reductions. Okay. But this is what we call it, supervised machine learning. Technically supervised machine learning. If anyone says the supervised machine learning, you have the data in both ways. You go right and you go left, and you just come up what is relation between right and left. That is the machine learning of supervised machine learning. Then we can call the another things unsupervised machine learning. What's unsupervised machine learning? You have no left, you have only right. For example, we try to make one data. What is the best way to separate it? So this is one of the unsupervised learning, but it has the several layers of unsupervised learning, but it's a very easy way to understand it. In this room, we are 1, 2, 3, 4, 5, 6 people are here. So if we have the recording of this 6 people's recording, we try to classify the voices. Okay. So at the classification, we make it 10 classification, 10 numbers of classification. How much are the best it fits? After that 9 classification, 8 classification, 7 classification, where the classification fits without much error. At 6, no? 6 peoples are there, 6 pattern of the voices are there. So we have the 6 pattern of the voice. So we don't know how many of them are there. We don't know. The one who are in the outside, in the online, who got the recording, let's assume it all of them are speaking, and who make it the classified, and while they are classifying it at the 6, if we can do that mathematically, we can do that the voice related one, we can make the mathematical model, mathematical representation, and pattern of the representation, we make it how many patterns are there. Fourier frontier spectrum, there is we can take it out that dismantle the voices, we can make some mathematical model. So where we can make it that the classifications, there are 6 people are there, we can find it. Same times we can do that what? So we can make some, yeah, of course, this is one of the interesting study. We just take it the drone video, we take it out all the roofs, type of the roofs, colors and all other thing. We try to make the group, 1 group, 2 group, 3 group, 5 group. It fits to the 5 groups like this. It fits to the 5 groups. So then we can make it what are the major character of the groups are there. 5 groups. Even though some minor 1 or 2 is there, it will not consider that. So we can make it what are the minor groups are there. And what else we can do that, and sometimes we can do the pine trees. One of my friend did this, the study who is now in the lecturer in Jaipur University, where who took the drone images of one pine tree in Malaysia, and after that with the leaf colors, who tried to categorize the how many colors are there, who make it 1, 2, 3, 4, 5, 6, 7, 8, 20, and we found it at the 20, there is more correlations comes up. Then who just distinguish the 21, and then he just mark it which are the areas dominated by this color, and then who just name it the different species of the pine. So those are the things, but for our engineering application, unsupervised learning, we can use it somewhere. Yeah, of course. We can't say that. Crack patterns. We can make that 2 or 3 crack patterns or 5 crack patterns. How many patterns are there? Of course, we can measure the vibration of the bridge. So at the normal conditions, we can make the vibration, how many patterns of the vibrations are there in the bridge. So if we are receiving some vibration not categorized in the routine vibration, we may already have it, 20 type of the vibration are there. So if we are receiving, if we are feeling, noticing some sort of the vibration not within our categorization, what we can say that some new vibrations comes up, we can go for something. So those sort of the studies, we can use it for the unsupervised machine learning. But in our course, we most of the studies, more than 80 or 90, I don't know the numbers, but the most of the studies with the supervised machine learning. That means we know both ways. And some reinforced, this is how we make it. How they scattered each group still is, we make it the number of the groups, and we make it some numbers. This is the arm where it fits very well. So it's a dominant number. You no need to be there. If it is 20 species, sometimes the very minor 2 species is there. So if we literally finding, the pine might have the 22 species are there, but we don't worry about that. That's the very small numbers. We don't worry about that. This would be in our the 8 numbers. Sometimes the 4 would be the most optimum number. Why? Rest of them are not talking, only to say hi, hello, that's all. No need to worry about that. So we can make it the different the numbers. So these are the numbers. So we know that we don't know what is the category of it, we don't know what's the zoning of it, and we can make of course we can find that how many type of the vehicles are there entering into the highway traffic. We can make the camera and length and wise, we can categorize it, and we can make the groups, 3 groups or 4 groups, which is the most practically the practical group, application group, which through which it's able to find the most effective way of grouping. And another one is the correlation is not the cause. So before going through this, the detailed one, some interesting story I can share. Sometimes the correlations are there, but there is no cause. One of the very popular example is that the O-level results in a Royal College, it's okay to name. So some school in a good school in Colombo, and one school in Hambantot. Okay, we just try to correlate. What's the correlation? We can see that the good school having the good results, isn't it? No? That's a correlation. But this is the cause. Sometime yes, sometime no. if you want to sure that is the cause, we want to normalize the sample. What we can know, how we can do the normalization? The one who got more than 175 marks only recruited on that school. So then if we want to compare the school course, what is the course of the school, we want to find it what is the got through results of that school of the students who had more than 175 marks. Then we want to compare the both students. So how much intuitively they are prepared. Have you got it? First one. What are the other normalization we can do? What is the income level? We want to set the income level, and we find the one particular basket of interval, basket of the income level. The students who are within that basket, we want to check the students with that basket. Then only we want to normalize every layers. After that only we can find a course, actual course. Might be very similar, sometimes negative. Sometimes negative, of course. But at the starting, what we can see that something different. Oh, schools, 99% pass rate, 90% pass rate. So always not with the superficial understanding of the data. Sometimes data having the deep meaning. So that's why we are going with the machine learning. No? Otherwise, we can Excel is enough, isn't it? Excel is enough. Okay. The another one is the. Have you got it? What I am saying, that is there any feedback from there, from online participants? Any feedback? Anything to share? So any idea about what type of the application we do at this supervised and unsupervised learning in construction industry? Can you, anyone? So these we have that 2-3 points now. Witness point, reviewing point, like that. These are witness point. If you are not answering, you will not go further. Okay. So do you have any ideas? I want to call the names then. Normally I do in my master classes, I just call him. If he don't reply it, I just don't continue. Just take the reason to sign out. Is there anyone you can, if you are in, yeah, several other the big constructions, while one of my friend, Hisham Milan from Jaffna, who did the one AI tools that train the model to predict where the cracks can initiate. One particular building, who just take the 8 type of the building for over 20 years and you just produce the cracks, where the cracks may develop, the scenarios of how many meters it is away from the coastal line, what is the wind pattern, and whatever it is, whatever the related things we can connect, and who just try to find it. And if it is the 20 the buildings, who just take the cracks of 16 building and learn the cracks and train the model and try to predict the rest of the four models. It fits, perfectly fits. 3D develop, it fits. So it's being applied in a very efficient way. So anyone who can share? Otherwise, have you gone to the? Don't worry, we will start the practical sessions soon. Don't worry. I think we are dealing with some concrete data. So is there anyone who can say something? Not only supervised and unsupervised machine learning, there are some other machine learning. There is a reinforced machine learning. I don't include those in these graphs. Reinforced machine learning. Have you ever heard the reinforced machine learning? Is the neons learn problems? No one categorize it for quotient of the. So these are the things. Yeah. Anyhow, I just give the introduction of the reinforced machine learning. What's the reinforced machine learning? We randomly take the steps. Some steps randomly taking. For the simulations, for the game simulations, we just take the random action and record the consequences of it. If the consequences is positive, we just give some rewards. If the consequences is not positive, we just punish them. And through which we just do it again and again. For example, if you are doing the Primavera, who are using the Primavera? The scheduling, the project scheduling, where if we are make the float, there are some activities float, not in critical path. So we can move it little bit here and there. While we are moving there, the resource optimization happens or not. So our consequences, we try to measure the resource optimization happens or not. This float, if you are moving this way, it's good enough or not, and if you give the positive points to move in such a way, and if it is not if you move this way, it's not positive impact, we just make it the negative one. So while contributing that, we can make a lot of the optimization in Primavera, but it's little advanced one, mostly which is being used for the game industry. So the game industry, in which way you want to move and how you want to shoot, and chess, how in which way you want to move, and all the times it's measured in reinforced machine learning. Make it and measure the consequences, and make it and measure the consequence, make the move perfect. Okay, that's a reinforced. Several other learnings are also there, which are very complicated, and this is how I try to understand the machine learning. Okay. I hope that this is the good stepstone. You can initiate, and later you can deepen the understanding. Of course, there is some imperfect introductions about those models, technically not correct, but it's generally we can acceptable this. So with that, now shall we go with one machine learning with the graphical one. Okay. Later we can go for the vibe coding. What's the vibe coding? Of course, it is the assignment. What's the vibe coding? So the one who is response last time. What's the vibe coding? They are chosen to be silent. Okay. So the vibe coding is that rather than using this coding, and we can use it the human language to do the vibe coding. You know little bit about the concept, so we have no issue to do that. If you know this type of 1 hour introduction, you are capable and you are prepared to do the vibe coding. That is the basic, the eligibility test. Okay. So we can go for the vibe coding. So firstly, let's go with the KNIME. There are a lot of the graphical source of the softwares are there, and I hope that you already installed the KNIME. Okay, so we can go for the one supervised learning. What's the supervised learning? You have the 2 feet, you have the 2 arms to reach both ways. What would be the influencer? What would be the influenced? Okay. Ah, 3, okay. Yeah, hydrological predictions are code with the help of AI. No, no. I hope that it's the generative AI, the LLM or something. Yeah, of course, that's a good answer. Hydrological predictions, we can do the hydrological predictions, but most of the models in hydrology, physics-based predictions. So sometimes these predictions, we don't know what is the logic behind that. At the time, we call it black box model. Have you ever heard the black box model? We just give the data. We don't know what's happening inside. But in here, the 1,000 students, only features is the 5,000. So we are able to evaluate it. Which has the higher influence. We can evaluate there is some other sharp, and I think that Dr. Pasindu will do that, who is expert in interpretations, and I think who did the very good papers and who will be, I think, the tomorrow who will introduce those things. And hydrological predictions are mostly not machine learning one. They do the simulation. Simulations means it's not the machine learning. It's something, but the machine learning models also there. In the structural ways also they are having a lot of machine learning models and concrete strength prediction, crack development prediction, and through the vibrations they can make it what sort of the overhauling or the repair, the maintenance to be done, and the vehicle related vibrations. Of course, one of the most important study I involved with the vibration of the compactor, we can find it what is the degree of compactions. Of course, no. We otherwise, what we want to do? You want to do the Proctor compaction, and you want to do the optimum, the maximum dye density, and then do the field dye density. You want to compare it. Rather than doing that, we have the data, 1,000 of data we have. We can find the vibration of the compactor, and with the vibration 10 we just convert the vibration able to find it what would be the compaction of that particular soil. So that is one of the most easiest example I can share. And if you go with some deeper example like the picture images also one of the data, no? We just take the data of the pattern of the pixel. So with the pattern of the pixel, what we can do that? We convert it into the data, and that data we already film. This is the pothole, this is the cracker, this is the base failure, and we can scan it road, and we already feed the data. This is what this. And then if you are scan the same thing with the new road, we can identify these are the potholes, how many potholes are there, how many edge corrections to be done. So if we feed it in proper way, our model definitely better than our technical officers, of course. So some of the technical officers doing these the estimations in 2015 Google Street, they don't know what's happening after that. So if we are doing some corrections, you don't need to know anything about this inside. If you know the tools in which way you can use, and a lot of the machine learning, the expert who are involving civil engineering projects, who are not good at, who are not expert in machine learning, but who are expert in application. Because one computer engineer cannot find these features and these issues in civil engineering, a very complicated one. So no one can replace your expertness. So by learning these tools, you can make the good way of applications with the data. Okay. So with that introductions, I think I hope it's good enough to step in to the so this data, this is actually published one. The data has been used for the several publication, one of which the very notable publication is that applying the sharp values and interpretability as a pioneer of Dr. Pasindu, who will introduce these the next tomorrow. So this data, I will show the data. Where is the data? Okay. Can you see the data? Data. Noise. Can you see the data? Yes or no? So can you see the data at the online participant? I think
Yes.
yeah, please.
Yes.
So what can you notice? So first thing is every row representing one data. Every row representing one data. So then the basic question is how many data it has. You already have this data. Can you find it? How many data you have now? Thousand? 1030 data are there. Is it okay? You got the data? Okay. The same 1030 data for online participants or one or two more? The same one? Can anyone find it 1030 data? With that 1030 data, so of course, thanks for messaging. Okay, thanks for messaging. So in this 1030 data, what our study we are intent to do, supervised or unsupervised? What we are intent to do? If you respond it, we can go a little faster. What we are going to do? Supervised data or unsupervised data? Okay, supervised data. So then what we want to do? First thing what we want to do? You want to separate the data, separate the columns. The columns are called features. We want to separate one column as the output, isn't it? So which one is the output here? Which one is the output here? Column? Yeah, concrete compressive strength is the output. Okay. So then we make the features as a different color. Okay. Then machine learn it? No, of course no. It will not learn it. But I just for yourself, I just make it it seems to be, let's for these lighter colors. Okay. These are features. Which one is output? Which one is output? Okay. So far you have the very good the introductions about these, and with that introduction let's go with the machine learning. So firstly, we just open the KNIME. KNIME is the open source software. Open source mean what? All of them are contributing and get the all of them are contributing and it's becoming, we can get it free. There is no any cost. So firstly, what we want to do, we want to read the data to here. How can we read it? Very easy way. I think even if you know the very good Python and very good C++, we can't read it in such a quick way. How can we read it? Nothing else you want to do. You make it the data. Data. So I just want to that the E mode open. Okay, thank you. E mode open. Just let me serve it somewhere. So very easy way, even if you know the whatever the program you know, but this is the easiest way to read it. I think the most easiest way to read it, you just go to the desktop. So the concrete data is our things, which if you are just clicking here and drop it. So it will read it the Excel. So here
So we have a
Only a new interface.
you can go to the home. Go to the home. Can you see that the home? And after that, make the new interface.
our home is in
Can you go to the home, all of you?
the, yeah.
And after that, there is any create the new workflow. Can you click that? Can you create the? So you can name it. How do you want to name? Supervised ML create. Okay. So how do you want to learn it? You can make it if you don't know what is the data it is CSV data or the Excel data. Easy way is what? You can drop it. Concrete data here. Click and drop it. It works. Okay. It's work, no? It works. Okay. Then it works, no? Any issues from online? If you know the Excel one, what we can do that, it's a AI connected, I think, which I started at the PhD times. At the time, it's very complicated, the KNIME. Now, at the last 3 months, there is a KAI where you can do whatever it is. What I remembered is useless, nonsense. Okay, so I think, it's becoming very easy and easy. I think so. I think that ice breaking or they get involved is the issue. So if it is Excel reader, if you execute it, where you can execute, apply and execute is in this way. Here is apply and execute, and if not, we can execute in down. So if you execute, so it will launch again, sorry. So you can please execute the data. So your one is that it's little advanced one than mine, but I just check the features, all of them are same, so I just keep mine because it's an open source software. Sometimes if any issues comes up, it's difficult to resolve. So before your class, I don't take any risk. That's why it's a little older version. If it is paid one, almost the bugs fixed. So is there anyone who has any problem to execute it? Because I know that you have to know that for the programming, especially the programming, how much hours of your involvement is the matter. It's not the matter how you are smart enough or whatever it is. It doesn't carry much. because you have to train your mind with the programming language and computational thinking. That's the matter. So it's normally says that the 10,000 hours of involvement, wherever it is, and you just learn it, relearn it, and forget it. The 10,000 hours is the climbing the expert. So 10,000 hours, at least you have the 2,000 or 3,000 hours, you are the amateur. You can do something.
You can give the Excel file.
Just drop, you don't do the, drop the Excel file?
Only
No, whatever file. CSV file, text file, whatever file, you can do that. If you drop it, it automatically identified as Excel. If you are doing the same thing in Python, you have to do the different writer. PD read Excel, PD read CSV. So that's itself enough having a lot of errors. But here you just drop it and you can, if you know the data, what you can do that, you can make the Excel reader. At the notes section, you can search it the Excel reader. I think this is what the easy way to do the first application of the machine learning. And so if you have the data, please try it. Don't follow me the same thing. You just try it with your data. So after that, what do you want to do? You have to guide me. I already said whatever I won't say. I already said. You have to guide me. What I want to do after this. We have the data now. You can read the data. Do you have any issues on the to do this?
Sorry for disturbing. I couldn't drop the file into this interface.
What saying?
It's nothing saying that round with cross.
Do you have the data?
Yes.
The saved data in CSV?
Yes. Excel format.
Just check it with that your data is saved properly. Without saving, sometimes you share those things.
Okay.
If not, you just make it in here the nodes. At the nodes, it's an
Yes.
Excel file, no? So Excel reader, you can see the Excel reader.
Yes.
If you can search it, if not the Excel reader, you just put the Excel reader here, and you can configure it. Where you can configure in here. Can you see the configurations? Where you can guide the place where the data is there. You can do the same thing again in different way, but the one I said is the very easiest way. So what's the next step? We collect, and you guys just go through my slides. The last slide, it says the steps. Firstly, collect. What do you want to do after that? I think it's okay for the one who are just discussing.
Yes, no, it's fine. Yeah. Oh, good. Thank you.
It's fine, no?
Yeah.
Okay. Do anyone have any issues on this? Okay, so we can make it firstly collect. After that, we will split. Split mean what? 80-20. So we are, what we can do that, you don't know how to split, you don't know. So then log into KHub in KAI, log in, and it will open the one Chrome page where if you can log in that, it will be login to the login AI. After that,
Can you repeat
just if you click it, there is a login comes up, you just click the login and Chrome will log in that. And then you just ask it, I want to know that what is the node I want to use to split the train and test data. So I think you have to, while dealing with these AI tools, you have to deal like the boss, okay? Don't be servant, always not to remember all the things. If you have any issues, don't worry about that. Sometimes we are worrying about, I forget it, my memory is losing. No, being a boss, always. No, I think that, no, this is not this. My data is in Excel where I to split the table. I think that the way we want to ask it, that the table partitioner, that's the thing we can use it. The rest of them also use it, but this one works well to me. I think you can use the separators, but let me use it this one, because I can't do any experiments on this while I'm doing the lecture, so you can make it. So then what you can see here, the data, this data you already executed. If it is the green in color, it means that it's already executed. This data to be connected to this data, where the partitioners comes up, where it's RC relative size, which size you want to separate for the training. There's a two part, no, training and learning, testing. Which part normally for this type of the very explicit data, we can make it 80. 80 is the good number, so I make the 80. How do you know the 80 or 70? Mostly 80. Sometime if it is the text data, 70. And you no need to complicate further that. And what is the random? What is the random? What is the random? In which way you want to split? Only the first 800 rows and last 200 rows? In which way you want to split? I just make it randomly select. What's the random? You just select 1, 8, 20, 38, 40, whatever you do, you just select. What's the random seed? Be consistent with the random. Okay, so then if it is random is correct, so it will choose in same set of the data, 1, 8, 16, 27, 89, it will choose same but random, there is no pattern. So if you change this random seed, it will correct, it will choose the different random pattern. Okay, so we just make it, and stratified means it make the group and select the same number of group, and linear and first rows, these are the things you can learn it. How do you want to learn? You just make the gate to the AI, and it says that my table partitioner gives several options. One of it is the sampling strategy, where stratified. Can you explain it? So it will give all the examples, and if you want, you can connect the table partitioners in which way it's moving. And we are now connecting to the cloud this. So you can ask that same question to the cloud. So these are step stones. So you no need to change most of them, but random is okay. So what's the duty of it? We want to execute. If you apply and execute, what will happen? There are two outputs are there. Two outputs are there. One output is what? It has 824 rows. Another one is what? 206 rows. What's that mean? It's splitted into the two way. So you can say that first partitions and second partitions. So you can find the randomness here. 6, 16, 27, 32, 34, 35, the second partitions. If you make it the randomness little change, that selection, the randomness will change. I think these are the steps you have to follow. I think you are with me? All of you are with me? Or not? So with that we can have the break. Can you hear me, no? Okay. So I hope you have already done this so far. So with that session, we can go for the table partitioners. We did that. We complete the table partitioner. That means that we can split out the data into the 80% and 20% of the data with the randomness. Randomness means whatever the random values, we just select it, not in order, some randomness. After that, what we want to do? We want to make the formula by using the 70%, 80% of the data, isn't it? What do you want to do after that? After the splitting that, we have to do the formula, one formula. So there are several one we can do that. We can make it several the formulas. in my case, I just starting with the linear regression. One message comes up. Yeah, someone else says, if anyone unable to do this much, unable to come extent of this, please raise your hand, we can help you. If not, I can go with this again. So, the firstly, we just make the linear regression learner. So, we can go here and make it the linear regression learner is what? We make it a into x plus, who is not coming, no? Okay, so linear regression is main a into x1 plus b into x2 plus c into x3, like that in a linear way we just connect it. So we try to make the linear regressions to learn this what? The training set of the data. And upper one is the training set, you can see that 824, and we just connect this with this. And then this data pipeline or supply to this node. Then you're going to execute it. It's going to execute. So if it is executed, this is the square shape of the something comes up, which is what? This is the knowledge, which develops some knowledge. Okay, they can hear my voice, no? They can. Yeah. So in here, what they can do is, they can get the knowledge of it. Knowledge is known, this the blue color symbols. Okay, then learning happens. You can do the open view. So you can't see anything here, but the learning happens. So it's learned through this data. Then what do you want to do? Then what do you want to do? First you should learn it, and then what you want to do? After the learning, having learned, what you want to do? Learning is the training. Then testing, we want to do the testing. We have the learn and we want to test. So to test way, we want to do the same application of this what we have learned. So there is the regression predictor. Regression predictor. We can call the regression predictor here, and this regression predictor to be connected with the knowledge what it's learned from the earlier learning, and it want to be predict. Which data it want to predict? Which features he should take to take the predict? Testing data, the 20% of the data, no? Isn't it? The 20% of the data connected to the knowledge what is gained from this 80% of the data, and it's able to predict. And after that we execute it. Can you see that? Can you see the difference? How many data we have here? How many data we have? How many columns we have? How many columns we have? 9 columns we have. Nine columns we have. Excuse me. So, can't you do that mouse with that highlight? How do you do that? So highlighter comes up. It's on setting. Annotate. Okay. Okay. Then. Okay. annotate and we can do that. So, yeah. This one. Okay. How many columns are there? How many columns are there? How many columns are there? In our original table, how many columns are there? 9 columns, isn't it? We have the 9 columns. But here the regression, how many columns you can see? 10 columns, what's that? So it's make the another column, it's predict the compressive strength by using these 8 columns. 8 is the features, no? 8 columns and predict it. So in here, this learner, can you see that this is what the feature engineering? At this learner, we can make it which columns are relevant. This is the feature engineering. If you are feeling that the age is not relevant, so the particular student's ethnicity is not relevant, the particular student's the eye color is not relevant, you just exclude it, not include it here. Have you got it? Yeah. Exclude it from there, and these 8 columns are now taken for what? Taken for what? For the learning. So here we can do the feature engineering by using your expertise on your civil engineering works. So but here what we can feel that all of them are relevant, or not all of them are relevant. The particular data set published by the university in China makes all the relevant columns. They already make the filtration. So here we make it the 10 columns. They make the 10 columns. So can you do this again? Then we want to do what? We want to compare what has been predicted, what is existed. We have the 9 columns. Now in here, in this data, it's only using how many data? The columns containing of 8. And the 9 is still there. We don't use it. But this 8, it produced one more. Altogether 10. Okay. Now what we want to do that, we try to plot. We can plot in several ways. Scatter plot. Scatter plot means we can do scatter plot, and we can connect the scatter plot. We can do that in a horizontal direction. Which one it should be? The horizontal direction is the existing strength. The vertical direction, which one should be? Prediction one. Have you got it? The prediction one. And execute. So it's randomly predict, not much match with that. So it's randomly predict. So at here, while we are doing the prediction, this is what the predictor, we can name it in how it should be predicted. So it's a concrete compressive strength. What is the column prediction name? So prediction of the compressive strength, prediction of the compressive strength. If we are doing the several prediction not only the linear regression, we are using the several tools, several formula. So we want to distinguish these formula. What's the formula? Linear regression, LRG, linear regression, and then apply and execute. So then what we can see that it's produced the 10 columns, but the last columns what's predicted is linear LRG. Can you see that? LRG. Then scatter plot, we can use it where we want to say that the y-axis should be practiced the linear regression. And maximum rows, select the plot and automatic, linear, logarithmic. We can see the logarithmic and all other thing. We can apply and execute. So where it's produced the graph. Then this is the quantitative representation of the what is predicted, what is being existed. So after that, what you want to do? We want to quantify these predictions. So there are a lot of quantification methods are there. You will learn it in later phases, R squared, RMLS, whatever it is, what's the benefits in between. It's not the objectives or intention of today's class. We just say that numeric score is there, and we just try to connect the numeric score. What are the things to be predicted? The relevance column should be the existing one, compressive strength one. The one we want to predict, the predicted column, and we want to find it what is the alignment, what is the compliance in between, and apply and execute. We can say that R squared is the 0.519. That means there is no much correlation it has. So are you with me? I think that do I want to slow down a little bit? The one who are in the online.
Sir, could you please go back to the linear regression?
Okay. Okay. So these until the table, I think who just finished the tea now. Okay. Okay. So we have the table partitioners. That means we have the two datas. One is for the learn and another one is for the testing. By using the learning test, we want to do the linear regression learner. That means one of the formula linear regression means it's try to learn it ax plus ax1 plus bx2 and cx, like in that formula it's try to learn. So in that we want to connect with the 80% of the data. With that learning, what is the target variable? We want to separate out the target variable. Rest of them, by using the rest of them, it try to correlate the target variable. So in our target variable, compressive strength is the target variable. And then we are doing the feature engineering. What are the columns are relevant to this target variable? We want to remove the religion, or we want to remove the ethnicity of the person. We want to remove the height of the person. As like that, we try to do what are the things to be removed. But unfortunately, we don't have nothing to remove. All of them are relevant to the compressive strength. Okay. Why? There might be a lot of unnecessary columns are there. Who is the one put the concrete? What is the temperature of at that time the concrete? Which are not much relevant. Those irrelevant columns have been removed by that particular data publisher. So then we no need to do anything. If you want, we just make it and just remove it. Then what will happen? The program will learn by the features only which are included in here. If you are excluding there, those features are no more relevant. So after the learning that, this is the learning knowledge. This is the blue color square is the learning knowledge. This learning knowledge should be supplied or to be connected to the regression predictor. So every learner have the different type of the predictor. So with this knowledge, we guide them, try to predict this 20% of the data in 206. Okay. If we are predicting that, it's developing some knowledge. It's developing some knowledge. So it's try to predict the new columns. So what's the column? It says that prediction LRG. It only comes prediction in the bracket. What is the column he is going to predict? But we are going the LRG to identify what is the formula. What is the method we are using, not the formula, technically not the formula. To understanding this at the initial level, I just say that formula. After that, we can do two things. One is that we try to predict, we try to plot it qualitatively, comparing our prediction, how much each are aligned with that. What is the one existed and what is the one is predicted. So we can see that there is no any alignment. If it is the 45-degree, one line, if it is aligned with line, what we can say that what you have predicted, what you have done, both are correct. For example, in here, if you have both of them are same one, if the both of them are same one, what we can see that is a 45-degree. But if it is try to deviate, our model is not perfect enough. That's the reason. That's the reason is try to deviate. So in here, if you make it the real one, it deviates. It's qualitatively what we can say that the way it's predicted is not much enough to have the actual prediction. In that case, we want to make it quantification. There is a numeric scorer. We can connect the both columns and numerically comes up how much are align each other. So then we just execute, and then R squared comes up. R squared means, root means, and all the comparisons comes up in between the two columns. So by like this, you can do a lot of learner at this graph. So I try to make it linear regressions, all the possible one I try to make it, and simple regression tree learner, and the random forest. In a random forest, you need some more the details like the how many the branches are there, how many leaves should be there. Those things you have to check it. But for now, you no need to go through in such details. And gradient boost also one of the another machine learning. You just accept it, what is the default setting, you just click it, and you can make the XG boost. What is the meaning value, what is the XG boost, you will learn it later. I think the next classes you will learn little bit about this XG boost and all other things. But if you want to know what is the XG boost, we have the lot of teachers with our hand, so we can make it. Can you explain? So there's an easy way to make it. You can go here. If not, you can call whatever the AI tools which are very trained with these new models. So for example, if you make the cloud, you just make the chat, or if you make the one. So it's easy, you can connect the data here at the file. Because of I have the 3 KNIME files, so which I have taking my all the power of my computer, and as well as the some vibe coding also running in down, so that's why it's taking the time. So in here, so you can ask here also, and if not, you just add those data in your the GPT or that cloud, where you can ask it the questions about what is the XGBoost, and if some feature data is missing, say age. I will come there. Okay, I will come there. Don't worry. Anushka Ruchira, I will come there. Okay. So in here you can make some additional resources. So these KIG agents is limited if you want to pay a little more, but the cloud is enough one, but if you are adding the data, stamp is not working well. So another issues comes up. These data most of the time, I don't know what's wrong with this. Okay, just leave it. No issue. We can test it. So sometimes these data we measure unintentionally. We just measure with the third party. We got the data from the third parties, where we can't expect that these data are found in our engineering students, so it will be perfect. Most of the time it's not perfect. Sometime it may have some data, sometime it may not have the data. So at the time, the one of the most important things after having received the data, you have to go with the cleaning. You want to make it in a proper way, then only you want to do is particle separation or something. So I try to make some basic particle, the filtrations at this here. So we try to connect the example data, where World Bank data I already shared with you, isn't it? One data I just share with you, the World Bank. So if you want to check that data here, why I check the World Bank data, that is a realistic data, so that's more complicated one. You can do whatever the filtrations, you can do it here. Almost all the versatile operations you can do by this KNIME. So you can see that some datas are missing here, some data missing, some said some data missing. So some datas are not present there. So some data is missing, and what we can do, we can, you make the new data set, or the same page you can make the new workflow. There is no issue. You can make the new data flow, or if not, you can make this new data flow at here. So you can make the new data flow, the data which can be connected and which can be operated in different way. If not, you can go to the home and make the new data flow. Where what we can do that, we try to connect the World Bank data. What's the World Bank data says? It's 328 and column 6 it has. No, I think that's a different data. It's a 31 column it has, no? 31 column has, and rows are 265. That's what's that mean? 31 features with the 265 datas are there. The first thing, we can make the row filter. Column filter is easy, no? We can avoid one column and we can take it out the another column. Row filter is sometimes is little complicated. So I make the several row filter. Firstly, you can make the row filter. Even if you do that some Python programming, it's not such easy to do the filtrations. Then this is one of the very easy way. What we can do that, firstly we just connect the data. Column 1, what do you want to do? What do you want to filter? What do you want to filter? The first column, we just say that first column, country code is missing or is not missing. We just select and execute, then it will find there is no any columns, I think. There is no anything is not missing. So it's 366. What is the earlier one? 65. What that mean? There is no any row missing their value. How can we confirm it? We want to find it is missing. Apply and execute. You can see that there is no data is there. So then that's the first one. We can say that one particular column not having the value, you just skim all the data. You can skim all the data. You can avoid all the data there. The first thing. If you want to do the row filter again, where we can say that row filter, the country's name, country's code, short name, currency notes, table name, Currency, where is the country's name? Country code, short name, or long name. We can make it the matches wildcard. We make it R or star. Send, apply and execute. Can you see that? It's a long name. All the countries with the starting with R comes up. So we can filter it, rest of it. We can filter it, rest of it. We can do the filter like that. And only industrial data with year 90s and 2000. How can we do that? Long the filter data. Where is that? Only industrial data. We can go to the industrial data. Where is that industrial data? So you, I think the industrial data, I just make it somewhere, I did missing. So the missing values, we can make it the currency. If it is not missing, we can make it execute. We can filter it. And we can filter like the row number, last 10 rows, or greater than 200 or lesser than 200. How can we make that lesser than 200, greater than 200? So is greater than, I don't know what's the number, row number, the income table 2 alpha code, special unit, income group, or national accounting, leading date, other group, PPP survey, system, government, largest population, greater than, missing. We can view how to go to the data. Latest industrial data. I can latest industrial data. Yeah, please. Thanks. Who is that? Mayuranki, thanks. who just find it? I say industrial data. Thank you. So what we can do that? We can latest industrial data. Year should be greater than equal to 1990s. Same times we can add the another criteria, another criterion 2, where we can make it lesser than 2020. So we can make it the rows which are falls in between the two values. So we can make it in such a way, we can greater and lesser. Likewise we can make the row filter. Even we can use it for several columns, several new flows we can get purchased here, but not purchased, we can buy it here, for example. So you can go for the KNIME flow. KNIME flow where you download, you just go with the templates. There are several templates are there. How to split the cells, how to naive Bayes models, one of the very advanced machine learning model, how to split the data and analyze the data distributions, how to aggregate the data, two data can be, how can you aggregate it, how to rename the column automatically. So if you are making rename it and it can be do the automatically. We have the lot of workflow. If this workflow works with our data, we can make it this one. And if you want to know that what's happening inside, you just try it in online. Try it in online. It will give the base to do some practices in online. And if you are impressed with the data it has, or you can say that what is the data it is, execute. It is online, no, it's online. It's not in my computer, it's online. So what we can say that column 5 and 150 data are there. So what this actually doing, this workflow demonstrate an example of the loop in KNIME using this data set. It iterates over the subsample and species column, and for each species it's compute the numeric and nominal statistics. So we just go with that one particular species. So this is one of the very famous data set of the iris, the flower detections, where I just go to the species. It has several species. So we can say that it is 5 type of the species are there. It's go to the species and collect all the species together and check out what is the mathematical range each and every features has. So it's just make the loop and calculate the statistics and validate the table and go over the loop the end of the class. What is produced at the end? So you can say that it's group it the different species and it's make the minimum maximum skewness, how the data spread out on particular species, how the data is spread out, how it's doing. Take out the one data if it is that belongs to the special length and serve it. If it is belongs to the width, it serve it, and all the things group it and make the statistics. So this is the one of the very basic introduction of the KNIME, where if you have the data at your hand, please start it to do the at least the what are the machine learning I just teach here, I just show it here. So no need to go each and every one. You just go here the compressive strength. You can go the compressive strength. You can at least do these 5 machine learning one, and we can do the predictions. You can see that I just do the the verifications, and after that I try to connect all the columns. So what's the column says here, this is what the compressive strength, what is existed, and these are the columns are what? These are the columns are predicted by the several other methods like the formula. So I just make it one column and I try to compare it which one is the best one. So that is my intention to do. The KNIME is not the very best software for the plotting. So if we can do the plotting, and we can do a later part, we can do some other methods to do the plotting. You have to know little bit Python to do the plotting. So with that node we can stop the graphical interface of the programming. So if you are okay with that, we can move to the another part of vibe coding. So what you can do that, you have a lot of times and you have the interest, and just go with that and connect the BOQ, connect the HSR. I did some work with HSR. Can you hear? Do you know that what's the HSR? Highway, of course, the highway schedule road, highway schedule rate. I just make some connection with the HSR and work together with the HSR, and some work I did in BOQ, and then extracting the works with the extracting the data from the BOQ. And so do you have any issues? And if not, we can move it. I think we are little bit, we have to catch up our schedule. Okay, this is any message, I think. Okay, so then let me wind up this KNIME. Is it okay? Do you have any questions in the KNIME? Let me wind up it. I will entertain. I think that the next week I will come, and if you have any questions, I will entertain those. So anyhow, just let me to close it because it's running my total computer power. Yeah, please. Yeah, there is the attendance. Please fill it. We will so critical on the attendance. We will know. Yeah, please fill the attendance. So after that, this is what we have discussed, the graphical way how we can invoke the machine learning. After that, what we want to do that, how can we do the machine learning or the programming or data analysis through the vibe coding. Vibe coding means writing the human language and to do the coding. In here, okay, so yeah, you just save it, and it will be in the workflow of the KNIME. It will create the workflow where it will save. Workflow of the KNIME, it will save it. So I already discussed this one at the Colab. Have you already opened the Colab and registered with your Google identity? Because it's a Google platform, you don't need to do anything other than just click the Google credential. If you go there, it's the Colab. What is the Colab? So this is the we try to do the same thing what we have done in here. So what is the Colab is? Colab is interconnected online platform where we can write the Python. C++ also possible where we can write the Python rather than installing something in your computer, and where a lot of the problems comes up and it's very difficult. So rather than installing something, we just call the Colab. Can you come to the Colab? And the new, if you want that, you can come up with the new notebook in Drive. Can you come up this? So here you can make it 1 plus 1. If you want to run it, shift into enter. Of course 2. So at the starting point it will take some time. 2, of course. So if you make it the print whatever it is, machine ML class, it will print ML class. So this is what we call it, the Python interface. If you do that if you are doing master on it, we have the lot of idioms. For example, what's that? Visual Studio is one of the code to write it. Visual Code, if you know the Python or C++, also we can connect it. As well as there is a Jupyter. Jupyter also almost same as the notebook LM, the Colab, but it is offline things. Without the internet, you can write it and you can serve it. We don't need the internet for here, even though it works on the browser, but you don't need the internet. For example, in here, if you make it the Colab, the circle detection, you don't need the you can make it, no? There, so far you can make it. Jupyter also there is here, one of the KLM which can be used as the offline. But anyhow, we just no need to involve with the offline one. It's online, no need to install anything. So where you can write your code here, okay? So in here we can make it. So someone else message. Can you have the workflow in KNIME? So we can check it with the hours. You firstly prepare it and later I will share. Okay? Okay, it's easy way to do that. So firstly you just prepare it and we can share it later. Okay. So in this one, we can upload the files directly to this online package. This online, whatever you're writing, not works in your computer. It works some virtual computer in the cloud, some higher power, it will work there. But you can't serve any data on that cloud computer. temporarily you can put it and search it and serve it. But if you open it again, that file is not there. So what you want to do, you want to serve all the things in your Google Drive, whatever data it is, you have to serve it in Google Drive. You want to connect the Google Drive with this cloud folder. So then every time if you are run it, it will go to the Google Drive and take out your data and do the testing. So firstly what we want to do that, these are the packages. These are the packages are available, freely available for the everyone. So these are the packages written by the freelancers to do the data analysis. We have to install it first, not in our computer, our cloud computer. I will put it in your message. You can type it and install it, type it and run it. After the run it, we can go for the next one. Have you run it? You run it? Or you are not getting that the text on? Text on. How can I share it? Can I share to the WhatsApp? Okay. But it will be taken. Do you have any issues to install it and copy it in first row and after that shift into enter? That means we run it. After run it, we can see it whether it's okay or not. We can see the corrections there. It will take some time at the starting. Okay, it says corrected. How about you? Not WhatsApp, you just connect to the Zoom.
The link is in the Zoom. Can you say
I'll link in.
So now I corrected. No messages.
Okay, no message, okay. But it will take the long text. Sometimes missed some important text. And you can type it. Struggling to do this? Anyone struggling to do this? We want to do it again. Yeah, I'll send it again. Anyone struggling to do this? What we are doing that, we just open it. Rather than installing our Python in our computer, rather than installing these packages in our computer, we just deal it with our cloud. So where all of the Python IDE is there, where we just open the Colab and open the new file, and then we just copy this and paste it. Huh? Not yet, not yet. They let them to do it. Otherwise, it's very easy. So we can share we can share this file, but no, you just do it. I will copy and paste each and every columns here, and every row here, you will copy it and paste it. So you get the ideas what is there, the reason of it, and later that tomorrow you learn about the Python, installation of Python. Sometime you may realize that how much versatile this tool is.
Share it again, no?
Yeah.
You share it?
Yeah. No, it's case. No, it's go to the yeah.
There's a session to share the K9 workload earlier one.
It's too old, no? I think how can I send to all? Or mini meeting the group chat. Meeting group chat, no? Is it okay? Have you got it? Sorry, I just sent it to someone else personal one. The case Harshana, sorry. Yeah, sorry. Yeah. Sorry.
Some guys are asking for the K9 workflow as well.
Yeah, just after the sessions, after they have completed, I can share my one. Shift into enter. Huh? Now it's Zoom. Yeah, it works. Okay. So I already say that it works. So I'm little worried because I connected so far long. So I'm just wondering whether it works or not. It works. So the first thing what I want to do that I want this is the folder it is. You can go and upload the folder here, and after that you can read the file directly. It's possible, but the problem is it's short term. If you are connecting the next time, it will not work. So for that to be a sustain, we firstly connect the Google Drive to this. Our Google Drive and Colab to be connected. For connecting the Google Drive with the Colab, we just make it this particular library. This is what we call the library. With this library to be installed. Again, what you want to do that? You just copy it and paste it. It will ask some permission to you to get the connect the Google Drive. Have you connected? Have you connect this? Okay. Then you just connect your data. You copy your data of concrete data into your Google Drive. Just save the concrete data into the Google Drive. And then you connect it until the drive. After that, what are the folders you have? My drive, in my case, my drive, something, and concrete data. So in your case, which folder it is, you just take that folder path and connect it to here. So what you want to do that, I just make it here and you just copy this. Copy this and paste it. So what you can do that, you can copy this, and content and drive is the common, and after that what are the folders inside that particular data is there. In your case, my drive, and it is directly to the my drive. You can say that my drive / concrete data XLS. If not, the my drive new folder inside it has, you just make that in new folder. Inside on that, you just connect the concrete data. So then I have already connected. So then my data is here as a data. You can see that how many datas I have, 130 datas with the 9 columns. What the data we have discussed at the KNIME workflow. So we are running out of time little bit. Please do it little quicker. We can discuss some the interesting patterns of this. You can do all the things what you can do by using the Jupyter notebook or the whatever the IDE. Here you can use whatever you want. Little faster than your local computer. Not the supercomputer, but little faster than local computer.
Upload that file to the drive.
कोई तो upload कर इंगे upload करने के my drive लेंगे where is it in my drive? Where is it in my drive? Where is the data? My drive. This is the data. What's the data? This one is the data. So my concrete data is where is drive spreadsheet, no? So then drive, that's concrete data. Can you go to that? Not the path, not the path. Just go to that column. It's I think it's directly to the data drive, my drive, not the drive, my drive and the concrete data. It's already connected. You just make the another one. Code. Another one. You just copy it my message. I think that is the part so critical for the online participants. So, do you have any issues? Of course, you should have the issue. So then what you have done it, you connect the data here. So firstly you want to connect the data, then so this is the path. What's your name? This is the path. PD read Excel, content, drive. I think in your case is my drive. There is no any folder you have, so you can read it. No? You can read it. Okay.
Ask Gemini how to do that thing.
Yeah, you can call again data.
So this is the
So what we are doing here, you just make the data. What's the data is? You can call the data again. Another code. Call the data again. Someone who are able to connect. Who are able to connect. So first thing, this one is the second row is not the big issue. You just copy it and paste it. The third row is before running that, you just save the data into the Google Drive, and then find it what is the path of it. So it might be drive, my drive, whatever it is. If it is new folder 1, new folder 2, whatever it is, and after that concrete data. If not, it's directly on the my drive slide concrete data. Likewise, the path should be connected. After the path connected, if you call the data, this is the data. We have the data. After that, what you want to do? After that, what you want to do? Split, no? We want to split which one is the X, which one is the Y, isn't it? So then, there is a generate option. There is a generate option. How about the online participants? If you are missing this path, we are unable to follow it. Do you need any help on this, or let me go with that flow? Can you see my... Anyone? Because if you are missing that, you are unable to follow this. That's why I'm a little worried about. Can continue, that's good. Okay, someone says can continue. So none of them are saying not continue. So what we want to do that, we want to firstly split out what is the X and what is the Y. So if you are making the generate AI, there is where with the vibe code comes up. Vibe code comes up. Where the vibe codes comes up. Here, what you want to do? At this data, what you want to do at this data, the last column, what's the last column name? We can copy this. Last column, so here it's struggling to connect it. Let's wait. I think seems to be the online participants are so efficient. Have you actually connected or not?
How to get path? My drive, me.
My drive, me, first drive, and concrete data.
Content drive.
You didn't. I think the sorry Pasindu that I just served that the data by your name. Sorry. All of them are typing your name as a path. Are you with me or not? All of you. So we can go here and generate that, all the data. At this data, the last column, by calling the compressive strength, this is called the compressive strength, is to be named as X. Why? That's a target column, no? It should be X or Y. No. It should be called as a Y, no? It should be called as a Y. Because that is a target feature. Rest of them are to be called as X. Can you these change? This is what we need. What we want to need? We want to separate the Y as a last column as a Y, rest of the column AX. You want to know the programming. How can we split out? Before 2 years, not before starting in 5 years, we want to learn this. We memorize this syntax, iloc x dot data dot iloc, and we learn this. But now it's becoming very easy. You just click this. And I just write it, the last column to be named as a Y, the rest of the column I name as a X, and you make it. So it will make the same the programming language what I did here. This is what I did manually. It's before 3 years before. But you can make it if you know the concept. By writing those in a human language in English, you can make it. Now what you can do that? You just run it. How can we run it? Accept and run. How can we run this column? Shift into enter. Can you run it in here? You can run X. What's the X is? The capital X, sorry. You can it. 8 columns. The only features is separated. The Y is what? Y is small y, I don't know. Y is small y. You make it the small x, small y. You can make it small x and bigger y. Okay. We have run it. After that, what we want to do? We separate what is the column value. So the online participants, if you need the time, if you need the extra explanation, please let us know. I think we can make it little slow. If you are following, if you are just listening, it seems to be all the things rosy and nicey, but it's not. You got it? Explain there. Go.
Now you need to separate the data. So X and Y columns.
Accept and run.
Separate the data.
Accept and run.
You can use that.
The table is not given.
You should get the data.
Yeah, you just run it. Accept and run. No, 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 no. It's not there. Drive me. Just go there. At the point. Drive me. No, no, no. Go there. Go there. Drive me. Which one you run it last time? Drive. No, top. Drive me. First day is correct. Click it. Drive me. My drive. First day. Just go again. My drive. My drive. Drive my drive, no? Content drive my drive. Content drive my drive. PD read Excel. Directory content drive my drive. Me. First day. Content drive my drive.
There is a space before first.
Drive the D capital D. Oh, D.
I think there is a space before one. I think.
Oh.
No space.
Hi. Are you with me, all of you? Can I continue? Are you? You can hear me, no? Yeah, okay, thank you. You can run it, no? Kajan and you can run it, isn't it? Yeah, that's good. Okay. Then what we want to do? The first things we did. What's the first thing we did? We just make it what is the feature and what is the target variable. We did that. Okay. After that, what we want to do? We want to separate the data or split the data. So what we can say that, please split the data. You just give the generate. You make the generate. And we can make it, please split the data into training and testing. We can name it X train Have you got the idea? No, we have the separate two things. We make it x train is one and x test and y train and y test. Have you got it? What we are doing that? We have the x data and y data. X have the 1080 column, 1032 rows, 1030 rows and 8 features, and the y is 1030 rows and 1 feature. So now we want to split out this x as a 2. One is the x train, that's the 80% of the data has, and one the x test, the 20% of the data has. Y test is the 80% of the data has. Y train is the 80% of the data has. Y test is the 20% of the data had. We just run it. It will create the. For that, what you want to do? You have to know the programming concept. If you know the concept, you no need to go the problems. You no need to the bother about the syntax and the programming languages. But you need to know what the concept. Okay. So then, what we do that? We can run it. And x test, we can check it. What is the x train? What is the x train? What's the x train? X is the capital. Have you got it? If you make the x capital there, x test and y train and y test. Y is the lowest one. It's okay. Say that 8 columns into 824. 8 column into 824. In here, the random state is the 42. What's the 42 is? Some numbers, whatever number it is. Random is, it's randomly select. There is no any particular order. Can you see that 995, 507, 334? If you make the 41, what will happen? You just remember it's 995, 507. The different number. But if you again the 42, what will happen? Why? Even though it's the randomness, it has some pattern to collect the random. Okay? To ensure that if it is randomness, if you're putting some numbers, it has some order to select it. So if you are repeating, it will be repeated. Okay. Now x train we have, x test we have, y train we have, y test we have. All of them are splitted here. After that, what do you want to do? After that, what do you want to do? Shall we do the linear regressions as what we did in earlier? So by using, so we can make it in here. I will send these all the text to him. I will send all the text to him, then it can be. So I will send the text, all of the text here, and you can, if you want, you can use it. Okay. So we can make the linear regression graph using linear regression please, why you are making please? No different, you just make it please to be humble. That's a denotation. Please learn from the X train data set with the value, with the target value Y train data set. Just click it. So it will call the new library, linear regression library, and the linear regression model, it's called from the linear regression library. It's a library, and then according to the linear regression is guided X train and Y train. So what will do that? It will do all the regressions and find some learning. So it tried to make it linear regressions here. So if you want to do that, so it's already learned, which is already learned. Then we try to make the prediction. No? We will try to make the prediction. Try to make the prediction by using the learning, X train, X test. Now we want to X test and Y test and learning predicts the learning by using the X test. Predict the Y predict. Have you got it? What we are doing that? Have you got the logic? We make it X train by using X train and Y train, make the model. And after that, what we are doing that? With the X test, with the same model what we have learned. What's the model here? Linear regression model we already learned here. This is the model we learn. By using this model, please try to predict the Y predict by using the X test data. X test data means what? The 20% of the data. So it will create the Y predict. So accept and run, it will predict the Y predict. Now what we want to do? What's the logic at another one is? What's your name? I forget it. Huh? Tulaja. What's the next step? Next logical step? We already predict. Then what do you want to do? Huh? We already testing with what? Comparing Y predict with what? Y test. So then what we want to do that? Please test my Y predict with Y test and make a graph, scatter graph where x-axis should be the x-axis normally X test, Y test, and y-axis should be y predict. Make the perfect. Okay, firstly we just make the graph and after that we can add it. So we just make that and we add one more code by clicking the, if you are making this one active, this row, it will be activated there. So if you click that, so what we are now doing, are you following my logical step? Okay, can you connect what I'm logically comes up? Okay. So then it's going with that, accept and run. Yeah, it comes up. You got it? It comes up. The same thing comes up. So you can do any changes here. We can make it, yeah. In here we can make the true values of y test. It's make it, and it's the y predict. Y label is y predict. It comes up, and x mini and all the things comes up. If you want to change anything, it will be changed. Here is the y max k is that black one and color is the red one. If you want to make it different thing, it's okay, and you can change whatever it is. And if you want to add, please add that at the so you can say that at the r squared at the graph area. What's r squared? So the how much it's aligned with. If we are both are in one line, r squared should be 1. Here we make it, we ask it that, yo, please make changes in the graph. So it says that its r squared is already, it is the 0.5, 0.95 is the location. This location we are trying to insert it. R squared is the 2RF, and it will make the r squared. R squared is what? R squared is the practically it's calculated y test to y predict, and that particular value is inserted in 0.95 to 0.05 to 0.95 relative locations. If you click that, again r squared is included, 0.63. So why those are different? Where 0.56? Where 0.63? Why? Why? The randomness. The randomness selected causing some differences. That's why the data is not such precise. So if you want any changes, you can change. If you want to change this line color, if you want to change anything, you can change it. You can do whatever it is in Colab, but if you know the programming, it's very easy to do that. But if you want, I can check my data analysis for the You can do a lot of data analysis stuff by using these. So it's a decision tree, that is a linear regression. What we did that linear regression. If you do the same thing with the decision tree, we can make it this one. Is the R square is 0.82. The R square is 0.82. So it's a tolerance limit. What you want to do, if you want to add the tolerance limit in our graph also, what we can do that, you can click here and add there. This is the one and explain the code. Can you add the tolerance limit tolerance limit 4 plus or minus 5 and plus or minus 10, and in between the area in between should be color with transparent different colors. So what I am saying that I make give a plus or minus 5 the tolerance limit graph, and in between the particles, in between the area should be colored. It says something. So before accepting, sometimes you want to check it whether it's okay or not. It seems to be okay. It seems to be okay. Why predict is not defined. So if any errors comes up, you just ask them to explain the error. Be a boss, okay? Don't make yourself struggle. Be a boss. If you are unable to find only, you just go through it. Most of the time, if we are, so we work together with the one, what? So the problem is we have to run from the beginning, because we just go with the different path. So in this time, if you run it again, what's the problems comes up? If you put it in locally, if you serve the data locally without the Google, what will happen? So you have to add again these the data again you have to add. So in here 29, 11, 31, 32, 33, 34. So you want to make the changes at here. At this graph, can you add plus or minus 5 and plus or minus 10 deviant range hatched with different color with transparent opacity. I will include a plus or minus opacity time areas further to demonstrate accept and run. You got it? What's the wrong with that? We have selected the wrong rows. So you have to do what? In here we want to do that. Anyhow, we will discuss those things in next classes if possible to discuss about the machine learning. I think the next tomorrow I think that Dr. Pasindu will do that, some machine learning, who is the pioneer to do this, the interpretability and all other things, who will discuss those. And the next sessions, next Saturday I will be here, so I can do some more on this. So with that note, shall we wind up? So are there anyone else in the online? Oh yeah, of course. 62 persons are there. Thank you for your participation. Please paste the Gemini chat, the commands here. Of course, I will do that. I think it's not in all chats are there. Yeah, recording will be there. Yeah, please go with that, and of course I say that the 10,000 hours is the mandatory to be a professional. We no need to be professional, we only apply some basic things. At least 1,000 or 2,000 hours engagement is required to understand this. Coding is always complicated, not like the easy what I am explaining, but of course you have to pay some attentions and spend some time. And please go with that and spend with some time, at least 5 hours on this coding, and be prepared before coming to the next session. With that note, shall we wind up? Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.